So moving on to the next question, we have maximum 69 number. So given a positive integer, now consisting of only digit 6 and 9, we return the maximum number we can get by changing at most one digit. Either 6 becomes 9 or 9 becomes 6. Okay, so that's a great question. So if we think of this problem some way, like suppose we are given a number as 6969. So in order to make this the greatest number, we can start from here, or we could just start from here and see what is the first point where we encounter a 6. So we can always increase this 6 to 9. So if we try to do this, I think this is the greatest integer that could be formed, because this value from 6 it has changed to 9. And since we are allowed to do only one change as per given in this question, you can get by changing at most one digit or maybe no digits. So it is, you can make either zero changes or no changes. So zero changes would be done when the number will only consist of 9 and not a single 6, because we can't change 6 to 9. Hence, if we encounter a 6, such as in this particular example, we change it to 9. If the example was only 99, then since we aren't facing any 6, the answer still remains the same. So what can we do is either we convert this into a string, its integer to a string, and then we could just simply replace the first occurrence of 6 to 9, and that could lead us to a better solution, a good solution, I would say. But here I'm not trying to convert the string to integer, because converting integer to string is just like it is it's not a good practice. Like if suppose the input is integer, then try to solve it in integer, because once you'll try to convert the string, uh, first you try to convert the integer to string, and then again to return the answer you have to convert it back to integer. So that would lead to an extra space, of course, while at the same time it isn't that space friendly or time friendly as well. Though it is order of n, that is n denotes the string, the size of the string, but still it's not that kind of good practice. So we try to solve it in by taking as integer. What can we do is we try to get the first occurrence of 6. And how will we be getting the first occurrence of 6? By dividing it by 10 and taking the modulo and finding the digit is 9. Then we move further and we will go to 6, we go to the next digit, and so on. So there are three things which should be kept in mind. The first thing is we should have an integer that keeps a track of that particular position. So how can we keep a track of that particular position? Either in order to change that 6 to 9, I must add, suppose the number was 696. So in order to make it the largest integer, that is 996, I need to add something. I need to add something. And what should be added? If you just take the difference, you would see it that the difference would be the 300, right? So we could always multiply this by 3 and we could change this. Possible crux of this problem is to generate 100. If you multiply 3 by 100, we could easily get 300. And how should we calculate 100? So what can we do is, for this particular position, we can call it I is equal to 1, our product is 1. And when we move on further, our integer becomes 10, our integer becomes 100. So basically this particular integer, it basically keeping track of that particular position to which that particular digit should be added in order to make that particular 6 into 9, because the difference between 900 and 600 is simply of 300. And once we get that particular power of 10, we could simply multiply it by 3 and we could add it to our result. If the 6 isn't present, in for example in this case the 6 it is present, so for that purpose the 6 occurrence would be a default answer. We could call it a -1, and then we'll check if the default answer is -1. That means we need to return this particular integer as it is, because it does not contain a 6. else we could just um, yeah, so we could just return that particular digit that we got. So we just try to type one temp equals num. We are modifying the temp variable for now. We are not using the nums because uh, nums. So we're keeping the track of the index as well. So for now, index is -1. This index variable, the index variable keeps a track of the first six that occurs on the left side. So what we do is we try to extract that digit. So this is the digit that we're extracting using modulo. If that particular digit equals 6, then we could easily do it index that particular index equals um, I, a particular I, right? And yeah, that's it. And what can we do is we can just increment that multiply or change our I variable from 1 to 10. So when it comes to the next iteration, basically I will be, the value of I will be 10, and again it will be 100, then 1000 and so on. And if the value of I is equal to -1, then we need to return num as it is. Otherwise, we have to return num plus something. We need to add something that is 3 into I, uh, and that's it. I think this will be cool. So, okay, I haven't done the division process. 10 to 2, 10, we should divide by 10. Works. Okay, I'm getting probably num plus 3. So, okay, so it's like it's getting twice. Uh, divided by 10 because we are getting an extra division that we don't want. So, because once we get to okay, so 9, 3, we're adding it over here. Temp, no, well, temp if digit is equal to 6, 10 is 6, IDs. Okay, it should be IDs. Should be index. For this particular variable, this gets, yeah, because there should be index as well. Try to submit it. I think it would work. Yep, it's working. Just as I said earlier, don't think about this because it depends on the internet, the internet connection, the RAM, the speed, everything. So uh, you shouldn't think about it. Just try to analyze it in order of big O of theta of something. So that's the asymptotic analysis which you should be doing and not relying on this. Next, so the next question is count substrings with only one decision selector. That's a previous question, so I'll leave it to you. And possible I'll try to upload that solution for this particular question afterwards. After that, we have this question, some of the digits in base A. So we are given an integer in base 10 and base K, return the sum of the digits of n after converting this n from base 10 to base K. Okay, fine. So what can we do is, we first try to take this integer n, we convert it into 6, and while converting, we calculate the sum of it. Also, we, if you just see that, okay, so let's take the first example. So we are given 34, the base is 6. So we try to extract the first digit, that will be 4. We try to convert it into base 4. So 9. So 34 will be expressed in base 6 will be 554, because if you just multiply this 6 4 24, okay, this is 6 to the power 0, so this will be just 4, and then 3 into 6 to the power 1, this will be 18, this will be 18, yeah. So if you just try to divide it, if you just try to divide it, you will be getting, of course, you will be getting 4 into 6 0. Then after we have 5, so 5 into 6 raised to power 1. This is 6 will be like this. Just a second. Right, so what we were doing is that we try to do this. Divided by 6, we get remainder as 5, we can portion it, and once it gets we into it 0 times, and we get 5 4, and then try to get the sum of these, or maybe we just get the 54 as base. Here we need to get the sum, so we just simply get it by taking modulo after each iteration and dividing it by 5. So yeah, that's a simple question. So while n simply do sum, track of an answer, return this particular answer, and then what we try to do is we answer plus equal to num n k, and that's it. And provide an answer. So let's see if it works or not. This particular input. So accepted. We can next question, that is okay. This question, right? So the next question was sum of digits in the minimum number, which is another premium question. So we can have cell dividing numbers. So we have a question: cell dividing number is a number that is divisible by every digit it contains. For example, 128 is a cell dividing number because, of course, it's divisible by the digits 1, 2, and 8. So, given two integers left and right, return a list of all the self-dividing numbers in this range left to right. So, we have been given a range to calculate constraints are 10 raised to the power 4. So what can we think of? What can we think of right now is, uh, yeah, so if it there's a simple observation, you can just simply see that the list consists of prime numbers. So every prime number which is present in between those two ranges would be present as a number in this particular list. And there are some other integers which are not prime but they're still present in the list, such as okay, if you take 1 will always be present. These are prime numbers. 4 is another variable which is self-dividing number, so that means like uh, every sing uh, every single digit number is a self-dividing number. And once we go to 12, I think 12 is also there because 1 and 2. So we could easily see a pattern that it's possible that is happening. That so if one of its numbers, or I could simply say that we might check for where if we are giving number n, then we could simply check for it if it is a cell dividing number or not. And once that happens, then we could simply just move further and do our computations. Like for example, if I give you any number, so the number is n, we could just take its digit, take its modulo, and we can divide it by a temporary number, which is the same value as the number, because this number will be, this particular variable will be used for computation. We store the original value over here, and then we try to compute do computation using that. We try to take the modulo, we try to extract the last digit using modulo operator, we try to divide it after each and every iteration, and then we try to check if contains that if it satisfies that condition. If it satisfies, then we append it to our list, else we do not. And yeah, that's pretty much it. So one of the solutions that I could think of is this particular solution. Okay, so let's try to code up the solution. So there's this one thing that the elements which are present between these two ranges, that is from left inclusive to right inclusive. And as the question says, so I consider that integer. So what can we do is we can have a vector returning our result. So initially the vector is empty, we have a function. So if I if it is a single digit number, or we are just checking for that particular integer, or are we checking, then discuss it later. We are actually pushing back this particular result over I, and yeah, so what is, we'll need to just declare a check function for num. We declare variable equals to num by m still greater than 0. We need to do something, and uh, yeah, so if int digit equals m 10 divided by 10 as well, and if num modulo if num modulo that digit, that particular digit, if it is not equal to 0, we can simply return false, because if any of one of the digits is not divisible, the whole condition fails and we can directly return false. If the entire thing has occurred, that means all of the digits have satisfied that particular condition, we can simply return true. And I think this would work. So if I is 0, so I is not 0, check. Yeah, I think this would work. False. Okay, so division by 0. Okay, if it is a division by 0. Okay, yeah, so division in each case, if there's a division by 0, we can straight away returning false, because for this particular test case it's accepted. So it's working for all test cases. So we move on to the next question, that is first n unique integers sum up to 0. Okay, so we need to find n unique integers sum up to 0. Given an integer, return any array containing any unique integers such that they add up to 0. It's a fairly simple question, so n is equal to 5. What can we do is, okay, so the output can be multiple outputs. I could feel that, yeah, these arrays are also accepted. So the simplest array would be, so we have two cases for this question. So let's just observe what happens when n is equal to 4 and when n is equal to 5. So these are the values of n. When n is equal to 4, one of the solutions that can we have is, since all of these integers are unique, so we can have -2, -1, we can have 1, and we can have 2. And this would return to 0. For n is equal to 5, we can have 5 digits such as -1, minus, -2, -1, 0, 1, 2. So if we try to generate for n is equal to 3, then we could simply say it is -1, 0, and 1. So you might have observed a pattern for n is equal to 7. If you try, it is -3, -2, -1, 0, 1. So you're observing this, that for n is equal to odd numbers, this 0 is coming every time. And then when we try to just insert the 0, the problem becomes similar to an odd question which is behind that particular number. So for x n is equal to 5, you just take this particular result and add 0 to it, and it would be in the same question. Okay, so like this is the problem. So what can we do is, we could just simply say vector int result, required to return that particular result, and if n modulo 2, checking if it's odd, if that particular integer is odd, then we can simply push 0 to it. And then apart from doing that, we could also one thing, we can have n minus minus. Why are we doing? We'll get to later. So what can we do is, for int I equals to 1, I less than n by 2, and that is also included. So for 4, as you can see, for n is equal to 4, we are going till 2. So we'll be pushing the positive element, we'll also pushing the negative element as well. So, and we need to repeat this twice, because 2 cross 2, because for each particular element you are contributing to two elements. So for n is equal to 4, you will be having running this loop from 1 to n divided by 2, and from 1 to 2, I think running this 2 times, and for 2 times it will be generating 4 combinations, because one iteration basically tries to generate 2 type of elements. So here, and then we could have simply push back both the elements that are actually present. One of them is I, and another one of them is minus I. So let's push back minus I. And this will be fine. So see, submit it once. Yeah, it's working fine. So we can move to the next question, that is, determine the color of a chessboard square. We're given coordinates of a string that represents the coordinates of the square of the chessboard. Below is a chessboard for your reference, and return true if the square is white and false if the square is black. Okay, so the thing is like that. We are given the coordinates in such form. A1, so A1 it is false because it is black. So we need to return true if it is white. So okay, if you could just have a simple observation, then we can see that from A1 it is black. From A1 it is black. And from H3, we could take A1 as a reference and see that what patterns can arise. So just see this particular diagonal. This diagonal has all the black elements. If you go to adjacent sides, then this would be another. This would be different white diagonal. This would be different white diagonal. This would be black diagonal, and so on. So what can we do? is we can try to keep this as a reference, and we need to check the that particular Manhattan distance for that particular coordinate. And for some reason, we'll have set of if-else conditions based on that. And if we try to see that if condition satisfied, then we could return something, uh, like if we might be returning true, or we might be returning the square of the square is white, and else condition will handle the black case. So if we see one of our observations, can we do it for H3? So for H3, what we can see is this is the H3, which is the white. So if we go here, so H3 would be 1, 2, 3, 4, 5, 6, 7, and after 7, this would be 1, 2. So if you could just see like 7 and 2, so if you're moving odd number of times, that is, if you just see the x displacement is the distance, the absolute value of displacement is 7, and if you go from the y-axis, if you see the displacement, then it would be 2. If you just add these, we'll get to see that the total distance would be 9. Then this would be the absolute value distance, that is mod of x of I plus 1 minus x of I plus absolute value of modulo of the y plus 1 and minus y of I. So if you could just see that we from here we could move to any other particular section. If you move odd number of times, then this would be white. If you move even number of times, then this would be black. So from that we could just simply derive out the that particular combination, and we could simply just it would be better for us. So we just calculate that particular distance which is present from that particular coordinate. So coordinates. Okay, let me just uh, shorten this out. So now CDS, so CDS of 0, which consists of letter minus a absolute value of this, and this shouldn't be actually this, not like this could be, this might be absolute, this might be not, because since this value will always be positive because I'm taking a as a first letter, and a is so it will always give a positive value. And the second character of the string would be displaying that particular integer character form. So I could just start from 1, which is the lowest integer, and if distance is 2, if it is odd, then we can return true, else we can return false. So I think this would work. Let's see. Works for this particular test case. Let's see, let's try to submit it, and yeah, it's working. So I guess this is the solution of this, and we can move on to the next question. Okay, so it's a Fibonacci question, and like this is one of the most popular questions that we have uh, across the entire C++ interview. Like this is generally the starting of the dynamic programming. Like if you try to explore dynamic programming, so this is the first question which comes up because it is based on that. So the Fibonacci numbers, if you don't know, it's basically when you try to um, 0, 1 as the first integers, and then you try to sum both of these, you get 1, you try to sum these, you get 2, you try to sum these like 2 elements, you get 3, try to sum these 2 elements, you get 5, you try to do it 8, and so on. So this is that particular solution. And what we need to do is, given n, we need to calculate fn. So simple, we just need to, for given n, we need to calculate fn. So the simplest implementation would be, can be a recursive one. If n is equal to 0, you return 0, and if n equal to 1, you return 1. After that, you return fib of n minus 1 plus fib n minus 2. the basic recursive solution which is present. So if you see that this is getting works for n is equal to 2, then this is one of the solutions which is present. And this is not an optimal one because it takes a stacked memory of order of n, and on space for the recursive call stack. If you don't know about recursion, if you don't know about the call stack, then I think you need to learn about it. So when you try to call these child functions, it will take up memory for each and every function. So it's not a optimal one. It's not a like good approach. So let's think of another thing. What can we do is we can have an array of it, and we could just try to using this particular recursive solution. We can just try to generate a array of it. Have simply f. For f0 we have 0. For f1 we have 1. And then we could simply just call it for int I is equal to 2, start from 2, I less than n, I plus plus, f of I equals, here it should be plus 1, f of I equals to f of I minus 1 plus f of I minus 2, and simply return f of n. Here we go. So this is like it's a tabulated form of result which is happening. So if you try to submit it, it will run. But still, if you would see, it will not be taking the recursive space. It will be taking for n is equal to 0. It's not coming out. So okay, so if n is 0, if base condition, then if n is equal to 0 or n equal to 1, we would simply return n. And it. Okay, so is 1 for int I equals to I less than plus plus f I minus 2 f I plus 1 f 0 1. uh right, run 0. Oh, plus 1. Okay, in the case of try to declare it, then it of course because f1 wasn't accessible memory, because for that particular case f1 cannot be possible for n is equal to 0. If you're trying to declare an array of n size n plus 1, then it would have been possible, it would result in runtime error. Hence we declared it to n plus 2. But still, this isn't an optimal way of solution. Like this was a recursive call. If you try to include some particular uh, like just memorize it or tabulate it, you will be able to achieve this particular form, but still you could optimize it to O1 of space. For optimization of O1 space, you can see that this depends from like this is like it depends uh, on f of I minus 1 and f of I minus 2. That is, you just need the previous values. So if you could just think of some way that you don't require that complete array, because of course you don't require the complete array, you just need only the previous two values for that. So we could think of that. We could have f0 equals f f1, and we'll have f2. Right. For now we have f1, we have f2, and f1 will be of course 1 in this case, and f2 will be consisting of suppose if the current value is f, so that signifies the present value. F2 means two steps back behind the f value, and f underscore 1 means one step behind that particular value. And you could just think of I equal to 2, I less than n, I plus plus. And simple condition, like we could have a int f that keeps track of that element. So f is equal to f underscore 1 plus f underscore 2. Now the previous value gets changed, so f1 becomes f, and f underscore 2 becomes the value of uh, f1. So it should be above this line, because you will lose the value of f1 once you try to change it with this particular statement. So you leave it here, and yeah, you're good to go. So if you try to return f, I think it will be returning the same value, and but it's more space optimized. Order of one is present. So see that now it's like for f. Okay, so if you need to, for base cases, you just need to, if n is equal to 0, then we return 0. If n equals to 1, we return 1. Try to submit it, get submitted, and it will have a lesser space and complexity. For now it's just the same, but it's an optimized order of one space complexity, because we are just trying to take care of two variables, max to max three variables. So yeah, and that's an optimal approach. So so this is an optimized tabulation or an optimized memoized form, and like this forms the basic crux of dynamic programming. So later on, when we try to solve questions related to dynamic programming, our process will start from here, from recursive call, and then we go to the memoized one or a tabulated one based on depending on the question, and then we try to optimize it space wise. So the reason why I explained this particular problem in detail is it forms the crux, the major part of dynamic programming. So I feel like you should try to solve dynamic programming while thinking of first the recursive idea, and then trying to optimize it, or try to memorize it and then try to optimize it. So yeah, that's pretty much from this question. We move on to the next question, that is the smallest range one. Okay, so what we can see is you have given an integer of array nums and an integer k. In one operation, you can choose any index where I lies between any of the array. Maximum value is nums dot length, and we can change nums to nums plus x, where x is an integer from the range minus k to k. You can apply this operation at most once for each index. The score of nums is the difference between the maximum and the minimum element of the range. Return the minimum score of nums k after applying the mentioned operation at most once for each index in it. Okay, so what is the question you're really asking us? is we are given a size of constraints, all constraints like be 10 raised to the power 4. We have nums, we have k. We try to change it, we try to change this, and we can apply this operation at most once for each particular index. For each index, we can apply this once, maybe once, and yeah, that's pretty much it from this question. So if we take an example that is 136, take an array element 136, value of k is 3, value of k is 3. So the question asks us that we can change this, increment this value either to minus or to positive or any of that. Once we try to do it, the minimum, the range, the score, basically the score of nums is difference between the maximum element and the minimum element. So the difference between the maximum element and the minimum element here 1 and 6 or any other number when we try to increment it, that particular difference, it should be the minimum. So we need to update this array and convert it to some modified array, and we need to return the difference, that is the difference between the maximum element minus minimum element, and that should be the minimum score of nums which is possible, provided we can do uh, k plus iterations, like you can do plus 3 or minus 3 depending on the question. So what I can think of is that I just try to pick up the minimum element currently and the maximum element currently, and I try to increase the value of the maximum element and try to decrease the value of the minimum element. And once it gets done, I could simply just say that hey, I try to increase the value of 1, so 1 plus 3 equals 4. This value I increment it to any other value, it's least concern for me. So for now I'm just keeping it 6, and the best thing is that you try not to modify the other variables which are present. So for now let's just make it 3, and then for 6 we could just make it uh, 6 we could simply make it as 6 minus 3. So that is 3. So currently, like, the minimum element was 3, and like 1 got incremented to 4 and 6 got incremented to 3, and we can take the difference between these two, and 4 minus 3, that will give us the value of 1. It is happening in this particular case, right? Okay, for this particular case the value is 0 because try to make this 1 into 2. Okay, so if we try to increment it by 2 instead of 4, we can have simply 3, right? So we can, so it's not necessary that okay, so it's given that the integer range for the range minus k to k, you can apply the operation at question. Fine, no problem. So what can we think of is uh, what I can simply observe for this particular case is we were given integers 1, 3 and 6, and the difference between the minimum element and the maximum element is 5, and we were given k as 3. So if this number is lesser than the twice the value of k, that is 6, then I could say that the difference should always be 0. Why am I saying that? Because there will always be a possible case where you can make these two numbers equivalent. And when you try to make these numbers equivalent, you can try to make each and every particular element between those elements equal to that particular element, and hence the difference between that particular element. So if I can make it 3, I can is always 3. I can make it 3, and the difference between the minimum elements and maximum element will always be 0. So if the number of, what happens when this particular difference is greater than that, then in that case, suppose we had 1, 3 and 8, and the same question is there, the difference is 7 for now, the maximum difference is present. And so what's the best thing that we could do is we can just increment it to the maximum that we could do, 4. 8, we try to decrement it, so value comes to 5, and then we take the difference that would be resulting in 1. So here we can do it. And in order to change 3, we can modify to any of the value, be it 4, be it 5. It's not to the concern of us. We are currently looking over the minimum element and the maximum element in this case, because these are the two variables which is basically contributing to the score. So like it's a simple int a is equal to, try to calculate the minimum element. Max element, and then you could simply just say if absolute value of a minus b is less than equal to value of cross k, return 0. Otherwise, we return absolute value of a minus b minus 2k. Typo. So it's working for this particular, it's working and gets accepted. So we move on to the next question. And the next question is Divisor game. Alice and Bob take turns playing a game with Alice starting first. Initially, there is a number n on the chalkboard. On each turns, the player makes a move consisting of choosing any x with 0 less than x less than n and n modulo x equal to 0. And we replace that number n on the chalkboard with n minus x. So also, if a player cannot make a move, they lose the game. So return true if only if Alice wins the game, assuming both players play optimally. Okay, so what can we say is, as given in the question for n is equal to 2, Alice chooses 1 and Bob has no more moves. So if we are starting from Alice, then Alice will make it 1, then Bob has no more moves because it is 1, like if also player cannot make a move, so it loses the game. So the condition is choosing any x with 0 less than x less than n modulo x equal to 0. So when the value of 1 comes up, we do not have any x which lies between 0 and 1, because there is no integer which lies between 0 and 1. So hence the condition here fails. So that means n is equal to 1 is our winning point. So when n is equal to 2, Alice takes 1 out of it, contributes to 2 minus 1, hence it is able to win. Now, in the case of 3, when Alice chance is there, so Alice cannot, right? If Alice wants to start, Alice chooses 1, Bob chooses 1, and Alice has no moves. So Alice will have to choose 1, so that will be 2. Bob chooses 1, and then like it's Alice loses this particular game. Also, if she could have chosen 3, but if she would have chosen 3, then it would have resulted in b is equal to 1. So in this particular case, right? So in this case, I think like 2 wasn't possible. For 4, what could I have done? There could have been 2 cases. So either make it 3, Alice would have 1 by making it 3, or when Alice makes it to 2, it will give a condition of 2 and it will not allow Bob to will allow the Bob to win, because if Alice takes 2 out of it 4, then 2 would be remaining and it will be Bob's turn. As we have seen in this particular case, for 2, the person who started wins, so Alice will be the winner here. So in this particular case, then we have 2 and Bob will be the starter of this game. Bob will be the winner. So we can see some pattern. We can see we are given that both of these players play optimally. So if all the players play optimally, then we could simply say that if a person loses at b is equal to 2, at a is equal to 2, when Bob loses, there is always possibility that Bob can take 1, that during its above case, that is when n is equal to 3, Bob can pick 1 out of it if the player is optimal, because he knows that once I try to pick 1 from 3, I'll get a game with the number as 2. And when the game with number as 2 will occur, I'll allow when the game will occur, it can be a possibility that Alice might lose. So in that particular case, Bob would play optimally, and here is the crux of the solution. So what can we say is for n is equal to 5, Alice chooses 1 because she knows that for 4 it is not an optimal approach. Like for 1, it could simply just say uh, like apart from 1 it cannot pick any other thing. First of all, because it's a prime number, whereas for 4 we have the chance of Bob. So Bob knows that if I try to change it to 2, I will allow Alice to win, because we have seen if the number is 2 and the name is Alice, then Alice is the winner. So it would just make it 3, so that when 3 option occurs, Alice will have no option but to take 1 out of it, and that gives him the chance for the Bob to win, because the number is 2 and Bob is the game winner. So we could just see a similar pattern that is happening. The pattern is that if it is an odd number, then we could simply say that return. If it is odd number, we could simply say that it's not favorable for Alice, so we return false. Otherwise, we return true, because that's the condition. During even cases, it is winning. Alice is winning for all even cases. For odd cases, since there is a possibility that you can always make an odd number from an even number by subtracting 1 from it, it will always be a winning case for Bob in case of odd numbers. So yeah, that was pretty much the solutions available, and we move on to the next question. There's a function, sign function, that returns 1 if x is positive, -1 if x is negative, and 0 if x is equal to 0. We are given an integer array of nums. Let what will be the product of all the values in the array. Returns signum function of product. Okay, fine. So one particular approach that we can think of is we calculate the product, and after that calculating the product, we could just simply take the sum of it. If it is positive, then we could return 1. If it is negative, we could return -1. If the product is 0, then we can simply return 0. But is there any better way of computing uh, the signum function? Because ultimately the signum function cares only about this the sign which is present and not the value. So we are given that if a particular value is greater than 0, the value will be 1 throughout that particular half. And if it is negative towards the left half, it is. So if you're talking about signum function is positive here, is negative here. If this is the x, if this is the axis, this is 0, positive here, negative here, and then it would be 0 over here. So it does not care about the value of that particular, be it 5, be it 500, the value of signum would always be 1. So we are only concerned about that particular sign, that element. So we can have a particular integer, because here in this case the number of values is 1000, and there might be a possibility that overflows may exist. So that wouldn't be a good solution for that. So we are keeping a track of the number of negative values. So int negative is equal to 0. I'm assuming it to be 0, and we try int I equals to 0, or we could just simply, instead of integer, we could simply declare boolean variable, which would yeah, simply just do it. We are assuming that the negative is 0. For int I is equal to 0, we could just nums. If I is less than 0, then we could have degree, so we could just do 1, we could just sort it to 1. And if I equal to 0, then we can simply return 0. We are saving a case for that. And once return degree is, if degree is negative, so if degree is equal to 0, that means we can simply return 1, otherwise we return -1, and that's it. Or we do not need to calculate the product of the values. And okay, so this is negative value. Also, this following test case, I think it will work. It's working. Next question. So let's just see the timetable, and we could see uh, how many questions have we done. We have done this particular question. This was a premium question. This was, we have done this question as well. We have done this question for dividing number, sum of digits in the minimum number, sum of digits in base k, and also we have done the sign of the product of an array. We have done the smallest range, done Fibonacci number, we've done Divisor game, and so we are left with 9 questions, and so we can move on to solve the remaining questions. The first question that we are thinking of solving right now is DI string match. So permutation of n plus 1 integers of all the integers in the range 0 to 1 can be represented as a string S of length n, where S has two options. Either it could be character I or character D if the value of permutation is less than the permutation I plus 1, and vice versa holds true for character D. In a string, we are reconstructing this permutation and returning it. If there are multiple valid permutations formed, we can return any of them. So here in this case, we are given a string as ID. So let me just move it and just see ID. So what have we done is for this particular string, 04132. So if we have I, that means permutation of I should be less than permutation I plus 1. So if Si is this, that means it should be an increasing one. Hence, we made this as 0 and we insert it as 4. And when we try to do as decreasing, then there should be 3, there should be 1. And when it is increasing, it goes against 3 because this is a choice which is available to us. So this is occurred when you're going to I, this I, second I, it should be greater, so we are going to insert 3 again. And once it is D, because if there is an increasing, then we can simply say if there's an increasing option, then we could just say that we have started to put as 0, and then if it is increasing, then we can call it 1. First one is increasing, then we could call it 1. And uh, the second one is also increasing, we'll call it 2. Third one is also increasing, we'll call it again I. We can call it 3. And so it follows a trend of increasing. So using this, if we see DDI, the last particular test case which is given, we go to DDI. So we start from 3, and then we are given an integer which is D. So for D, what we'll try to do is we will use 2, and then if we go to the second D, again decreasing, we'll go to 0, and then increasing, then we'll go to 1. So here in this case, as you can see, this will be the answer that is generated, that's 3201. So when we have characters I, it asks, allows us to solve question in a different way, and when starting from D, it is allowing us to do different. So when D is present here, in this particular case, if we try to use D here, that means the next integer which is coming after 3 is lower, is lower. And hence we could just insert either 2, either 0, either 1. So basically what type of character are we building basically depends from the last character string which is present. And we could just see that we need an integer I, which is generally required to basically when the character I is required, we generally want to move from a lower integer to a higher integer. So we can't think greedily in terms of that. Like we cannot put a 1 or 0 in place of 2 for this particular problem, for this particular test case. Reason being, we have I at the back, and in order to get an increasing sequence, we need to have some variable which is greater than the past variable which has occurred. So if we try to do 3 0 and decreasing the if we encounter the second D won't be possible in this case. If we have 3 or 1, the second D would be possible, that is it would be 0, but the increasing cannot be possible. The increasing in this case can be possible, and this could be a possible answer as well. This could be a possible answer as well. So we talk about it when we do from D as this can be considered as a possible answer for this particular test case. So this question basically asks us to get a permutation that could satisfy these conditions. So I'm taking the last test case for now, that is DDI. So if the first particular character is D, then we can simply say that okay, the first element out of the 4 elements that need to be placed, we could simply call it D. Right? We could simply call it the last element that could happen was 3, possible was 3. Out of 3, 1, 0, 2, the last element that could possibly occur was 3. And yes, this has been taken. If we move to the second element, that is character D, what we do is before that, we try to keep a track of two elements. One which is the smallest possible element that hasn't occurred till now, that is 0, and the greatest element that hasn't occurred till now, that is 2. And based on the conditions, if else conditions, we could just simply use those two numbers in order to generate our particular test case. So if we suppose we need to go, suppose in this particular case, we have D, we might have two options to consider. The second character is D. That means we need to go down. We need to go down. So that leaves us to one of the options that we could think of. So if we try to use the smaller element that is present, the greater element that is present, so that gives us 2, and this gets decremented to 1. Once this gets decremented to 1, as you can see, we don't have any option for it. So instead, when we have D as a character, we, rather than using the topmost element, we should use the lowest element that is possible, the smallest element which is possible. That means we go to 0. And once we go to 0, so before putting the value of 3, what we can do is, uh, let's just try to start it from here. So when I is equal to 0, we have two conditions. We have the kept a track of the smallest possible variable that would be placed here, and we have the highest variable which will be placed here. And if we encounter our first character, that is D, we try to push 3 over here and decrement this. So this gets to 2 and this is 0. When we encounter the second D character, we again try to push D, as this would be creating the least difference and would help us saving more elements for the future. And here it's 1, here it's 0. Once we try to get over I, we'll, instead of this element, we'll try to place element over here, and this gets incremented to 1. Finally, since we have completed our traversal for the string, we push the remaining element which is present, and that is basically the value of the left variable or the right variable. Any of these would be the same. So how can we do this? So, like, it's basic uh, traversal of this. We can have two variables. We can have int l is equal to 0. We can have r is equal to s dot size, and we can have vector. We need to declare vector s r plus 1, right? And for int I, or we could just add ch s, if ch I, then we could just say that res of I equals to L, and we try to increment it. So L plus plus, else res of I equals to R minus minus, and then we'll try to do res of um, yeah, so the last would be res of I, let's say int I is equal to 0, char of ch is 0. Instead of character I could just simply say for int I is equal to 0, I is n I plus plus, I declare n over here, n is equal to size, and instead of this I could simply say that if s of I is equal to I, then res of I is simply we do it here. Otherwise, res of I equals n, so this returning the res. Okay, so res of I, okay, so instead of this we could just, since I is declared inside the for loop function, for loop, not works for this particular test case. I think it will be for well, yeah, it works. So the major crux point was that we are trying to use those characters. We are pushing those those characters that have pushing those characters and marking them as placed, marking them as placed, marking them as placed, and keep a track, keep track of min and max variables that could possibly occur. Okay, so after that we move on to the next question, that is maximum number of balls in a box. So you work in a ball factory, you have n balls number from low limit up to high limit inclusive. So n is equal to high limit minus low limit plus 1, and an infinite number of boxes numbered from 1 to infinity. So your job at the factory is to put each ball in the box with a number equal to the sum of the digits of the ball's number. For example, the ball number 321 will be put in the box number as 3 plus 2 plus 1, that is 6. The ball number 10 will be put in the box number 1. So we are given two integers, low limit and high limit. We try to return the number of balls in the number of balls in the most number of balls, right? We need to return that particular uh, value of that particular box number, right? So by looking at the examples, I could simply see that it requires us to have an unordered map of all those box numbers that could possibly be there. So we have a particular box number that is present. We have a box number. We have an ordered map which keeps a track of this box sum. And here's the key is sum and the value is count of such numbers. And we try to calculate the sum of each and every particular element, the particular digits, and hence we are able to get this particular sum. So it feels like this particular approach would take max to max the O of n, a big O of n, that is where n, the value of n is high limit minus low limit plus 1. Another thing that I would like to talk about is the constraints here are raised from 10 to the 5 to the 1. So a good approach is that we could simply just try to uh, run this for loop, and of course it would work. But the thing is that it won't be like we could instead of doing it for each and every function, we can do it for one particular value, and based on that we need not to do it every other time, because if we know the number of digits which are present in 1, we could simply just use it to calculate the sum of the remaining other digits. Like if it is 2, then it will be of course 1 plus 1, and then for 3 it will be similar case for 3, for 4 as well. So here at that place we could be saving the time for that unordered map. Another observation that we can think of is that if the high limit is raised to till 10 raised to the power 5, so what could be the maximum digit that could be generated? That would be 5 times 9, I guess. And yeah, we have this sum would be highest, of course, and this would be having a sum of 45. That means we are given only there could be a maximum possibility of only 45 boxes. So if we even we are declaring an unordered map, the maximum size of that unordered map will be 45. So I think this particular combination, like this particular space optimization, shall not be like it should be done. It cannot be done. It can be avoided as well if we need to do it in order of one. For if we need to do it in order of one, it would take more. It would be having more edge cases in computation. For example, uh, suppose our low limit is 1, so we know the answer to our 1 value of 1, and for 2, 3, 4 it will be just the difference. Once it reaches 9, it will be this following the same pattern. Once it gets to 10, That means the digit value of 10, that means if you do divided by 10, it will be some positive value. And for that, we need to just minus a value that should be equal to 9. I think that would be the value should be equal, different would be equal to 9. And the 1 and 10 would be having the same value. So this we will be subtracting 9 from this particular number and then be doing the further computations. I mean, you can go through that part and try to solve it in O1, but for this particular question I think it's already in O1 because the maximum value would be for the number of boxes which would be possible is O of 45, and I think big O of O45 can be similarly be crossed as like we could be just it's just simple order of one space. So instead of unordered map, you could just use int boxes. The size of the boxes would be 45. So here I am declaring 46, maximum possible. That can occur, and yeah. So for int I is equal to low limit, that is I less than equal to high limit. Both of them are inclusive. So make sure to include both of these values. After that, what we can do is we can just simply increment it, that particular value, box I plus plus. So we're not using the box I value. What we are trying to do is while I we are doing sum plus equal to I modulo 10, I 10 and sum equals to 0, sum plus equal to a, and then box of sum plus plus. Then we return the maximum element of the box, that is box dot begin end. So yeah, that's pretty much it. I think this would work. Let me see. Box dot begin, not a structure, union. Okay, so we need to just yeah. So instead of array, I could just declare a vector box of 46, 46, and there should be 0. And we would exceed it because yeah, I'm using the same I for computation and the same I for incrementing it for the for loop. So instead of I should use a temp variable to do the trick, which should be useful for the computations for calculating the sum. So to do this, otherwise for this particular test case, let's see if it works for other test cases or not. Yeah, it works, and the major takeaway point was that if you just see the maximum value that could happen, it is over the 45, only 46 boxes or 45 boxes could survive. So if you want to if you want to optimize it to O1, it's your choice. But in my case, in my opinion, I feel that the complexity won't matter because maximum number of boxes, the maximum number of vector size will only be 46, and 46 is a very less number when you are comparing in front of 10 raised to the power 5 or 10 raised to the power 8. I think it's a very less number. It won't be mattering too much. So let's move on to the next question, that is the minimum cost to move chips to the same position. We have n chips where the position of ith chips is position I. We need to move all chips to the same position in one step. We can change the position of the ith chip from position I to position I plus 2 or position I minus 2 with cost 0, position I plus 1 or position I minus 1 with cost equals to 1. So we are given a coins which are placed in particular positions, as you can see in the figure. What can we do is we can just try to move all these chips to the same position. And in order to do that, here the output is 1 because we decided to uh, Okay, so we decided to move all the chips, move the chip at position 3 to position 1 with cost 0. And second step is move the position at position 2, position 1 with cost 1. Right. So I think it's here is the question for all these positions like position 2, position 3. So what we did is we tried to bundle them into here and we try to shift them into the same position. Okay, so one of the observations that I was able to figure out was that if we have, we could simply place all the even positions. Like if there are coins which are placed, like if coins which are placed, if this is a five-sized array and the coins are placed at every element of that array, I can place these elements, and these elements together, and I could place these elements and these elements together. Because the cost, as you can see in the question, the cost of placing position I plus 2 or position I minus 1 is at a cost 0. That means I can bundle these particular coins at one place. Let's just say I just bundle it here, one place at 1, 2, 3, and I can use these two coins and I can bundle it over here. And then I just need to return the minimum number of coins which I need to place over here. Either I can place this particular packet over here or I can place this particular packet over here. So I just need to find the number of coins which are over the even indexes, the number of coins which are in the odd indexes, and then return the minimum of both of these values. The, this value A, this value B, both should be initialized to 0. And what can we do is we just for int I position, if I is an odd integer, then we do A plus plus, else B plus plus, and then we return the minimum of A comma B. The question works for this particular case. It would work for, yeah, it's working fine. So yeah, this was a pretty easy question, and right now if you see, we have done this question, we have done this question, of course, minimum cost to, we haven't done this question, right? Yeah. We have done, okay, so this was the minimum number of minimum cost to move chips, right? So yeah, and still there are some 6 questions left to go, and the next question. The next question is regarding the projection area of 3D shapes. So we are given an n-cross-n grid where we place some 1 cross 1 cross 1 cubes that are axis aligned with the x and y axis as shown in the figure, and we view the projection of these cubes onto the xy axis, the yz axis, and the zx planes. Projection is like a shadow that maps our three-dimensional figure to a two-dimensional plane. We are viewing the shadow when looking at the cubes from the top, the front, and the side. We need to return the total area of all the three projections, right? So if we try to view it from the top, we can see that if we try to just visualize it, this question is more of a visualization problem rather than a normal problem. So in order to make this better, I feel uh, let's just focus on this particular diagram. So I'll try to make this diagram in a very clean way possible. So this is the x-axis, this is the y-axis as shown in the figure. I think I'm drawing correct here. And this is the z-axis, right? This is the z-axis which is going. So this is one particular cube. This is one particular cube. This is one particular cube, and this one more particular cube. Okay, drawing is pretty much bad, but I think we could just see what is happening. So we have one here, we have one here. It's value of 2. So we have one more here. one more here, and there's another value of here, and another one is over here. If you're seeing it from this side, you're actually seeing it from three different planes. So if this is an x plane and this is y plane and this is the z plane, which consists of the heights, if you're watching it from here, you're keeping the y plane fixed and you're watching it in terms of xz directions. If you're watching it from the top, you're keeping the z plane as fixed when you're watching it from the xy planes. So if you're watching it from the top, you will be only seeing the xy planes. You will not be seeing the z height. You don't care about the height anymore. And once you don't care about the height, you will only see that the four projections are able to occur. We're seeing it from the y plane, the x and z planes will be visible, so you don't care about the depths, the left side of these depths. You don't care about these depths. As you can see in the mouse pointer, you don't care about these depths. You are seen from this particular side, and you could simply see that this is like this is a simple view from the x plane. So we just simple this particular view that I'm talking about. This particular view. This is the second view that I'm talking about. That was the first view, and the third view is basically this one. Third view is basically this one. So how did you see it? How did you see this? Basically you saw it from the first side which is possible. So the first side, which was you could view it from any of the directions. You could view it from here. You could view it from here, from the behind of it. So it would be describing the same particular projection as far as that is concerned. So you don't care about these heights anymore. You don't care about the x coordinates anymore. You can just you're just seeing from the x plane. You just care about the y and z coordinates. So you don't care about x coordinates, and hence uh, like this is just an opposite projection. I mean, the projection is correct, but it's not this plane. It's behind of this plane. Like you're seeing it from here. So currently the person is seeing from here. This is the third view. It is basically seeing from this side. So it's getting the same picture, but in mirror form. But it won't really matter for us. So the question asks us to calculate the particular area of these projections, and we're done with solving the question. Right. Okay, so basically this problem has three parts. We need to calculate the x and y projections, we need to calculate the yz projections, and we need to calculate the xz projections, and we need to sum all of these, and it will lead to a specific result. Right. So we have divided these problem into a lot of tasks, and let's just try to do it. So let's just focus on calculating the xy coordinates. So when we are trying to do it in xy coordinates, I feel uh, this these basically represent the heights. We are not caring about the heights because if it has a height, then only the blue cell is indicated, and the blue cell is blue. If the height is 0, the blue cell won't be blue, and then it won't be shown. So the only reason that we can infer out is that when we are viewing the xy projection, the number of blue cells would be the size of the matrix minus those cells which have height as 0. Now, as you can see over this particular thing, we have height as 0. Now, why am I saying this? Because at grid it's 1, so at grid at 1, we had grid ij is represents a tower of v cubes placed on the top of the cell ij. So ij 1 2 has 3 cubes, 3 4. So 1 2. So as you can see that grid ij had grid I had 1 cube over here, had 2 cubes over here. So like grid I had 1 cube over here, 2 cubes over here, 3 4 had 3 over here, 4 over here. None of them are 0, but in this particular case one of them is 0, and that won't be contributing to our particular answer. That means in order to calculate the number of buildings having XY projection, in order to calculate the XY projection, we just need to multiply, we just need to get the rows of this particular grid, we just need to get the columns of that particular grid, and then we need to minus those particular values which have the value as 0, because that won't be contributing to the height. Now we move on to the second part, that is the XZ part. In order to calculate the projections for the XZ plane, I would say keep the Y fixed, and then we could easily able to observe this pattern. So if we keep Y as fixed, we don't care about the Y heights anymore. We are viewing from here. As you can see, if we are seeing it from the XZ plane, as you can see over my pointer, we are seeing it over from this side. We are seeing it from here. So we could see the maximum height as 2. We could see the maximum height from here as 4. And these are the projections which are getting displayed. So we could simply say that the projection in the XZ plane would be the maximum of every row. Is that correct? I think we could simply say that. And there's some for same goes for the YZ projection. For the YZ projection, we could simply see that the maximum maximum value which are present over the column, like as you can see for the first value for the first column, 1 and 3 are here. So of course 3 is greater than 1, hence 3 is getting displayed over that particular projection. For y is equal to 1, I would say 2 and 4 values are present, but since 4 is a greater value, 4 is present, and so it's getting, this is contributed to this particular variable. So I could say that for the XZ plane, I would say that we need the maximum row value, sorry. For the YZ plane, we need the maximum column value, and for Z plane, we just need those value functions which are greater than 0. And yeah, that's pretty much it. And we could just solve it. Int answer equals 0. We return answer as answer, and we do an iteration. We do of course a grid iteration would mean an O n square approach. That's completely fine. Grid dot size I plus plus j is less than grid I dot size j plus plus, and simply, so what we try to do, we int x y, make it as 0, make it as 0, and uh, simple. So x is equal to maximum of x and the value of grid of ij. Here we are able to calculate the maximum row. For column, to get the maximum column, of course, there's this trick that's, or not just no trick, basically. We can, instead of calculating it and passing through another traversal, we could just reverse the interchange the coordinates. Instead of ij, we could do grid j of I, and then we are able to get the maximum from every column. And after that, we don't need to do anything. If grid of I of j is greater than 0, of course answer plus plus, we are directly we are incrementing the number of positive values to answer, and then answer plus equals to x plus y. Yeah, that's pretty much it, and then we are returning the answer, and this would mean using this we could get our answer, and it's getting accepted, and it's submitted, it's accepted. So we can move on to the next question, that is matrix cells in distance order. We're given 4 integers, that is integers row calls R center and C center. There's a row called matrix. You are on the cell with coordinates R center, C center. Return the coordinates of all the cells in the matrix sorted by the distance from R center, C center, from the smallest distance to the largest distance. You may return the answer in any order that satisfies this condition. and the distance given is using this particular variable, that r1, c1, c2. So we are given rows as 1, we are given columns as 2, r center is 0, c center is 0. Let's just draw it for our own purposes. We are given rows as 1, we are given columns as 2. So for row 1 columns 2 we'll have such kind of matrix, right? And then we are given a center as 0 comma 0. So we are here, and the distances from view. Okay, so we need to learn the coordinates of all this in the matrix. It's sorted by the distance from the R center and C center, from the smallest distance to the largest distance. You may return the answer in any order that satisfies this condition. Fine. So that means we will have a vector, and that basically consists of the distances of for each and every particular cell. So that means we need to generate and we need to generate the distances, and we need to sort these distances from the smallest distance to the largest distance possible, right? So for this particular index, as you can see that this was called 2 for integers. It's r2 distances from 0 comma 0 to other cells are 0 comma 1, right? So right, distances from 0 1 to other cells 0 1 1 2, 1, it is 0 1, right? We need to return the coordinates of all these cells in the matrix sorted by the distance, right? Okay, so we need to sort it, and based on that we could just use that particular sorting, right? So what can I think of is that we can use an unordered map, and for each and every coordinate we can just pour out the distances. Use a key value and key value pair. So the key would consist of the coordinates and a pair of integers, and the value would represent the distance. Based on that, we can apply a sort function, and we could simply sort those particular elements. So what am I thinking of is that right, I could just simply implement it by code. So what I can do is I can think of instead of first, let's try to generate vector of integers as soon as possible. So this is the resulting vector, and I need to return this resultant, and R center and C center are given. So first, what I'll do, I'll try to generate all the possible combinations that can occur. So that is rows I plus plus for int j is equal to 0, j is equal to 0, and less than calls j plus plus. What can we do is we can just try to push back all of the coordinates which are possible. So that would be result.pushback. Let's make a vector of it, and the vector would be I comma j. So the vector would only have two values, and we could just push it, and this would result in getting a vector that is resultant, and you could just sort it, right? You can just sort it on the basis of, you could just sort it just dot end. You could just sort it based on a comparator function. Now comparator function does what? Comparator function has thing, because what can we do is auto comparator function we can make it. So auto comparator function, so the comparator function, and what can be done is comparator function consists of some arguments, and we could just use that comparator function in order to generate. So it consists of two values, that is vector of int star a, vector of int uh, a percent b, and it does something based on some global variables. So what it does, we need these values, we need these values as well, and we need to make a comparator out of it. So how can we do that? We can either declare a comparator inside this particular function, or we can make the general practice is make outside of it. So what can we do is, instead of putting here, we can just use a type of comparator sorting that is possible over here, which is if we try to push the inputs which are generally required. So we go here and then we try to declare it uh, just like a function, just like a normal function. So it consists of this vector, which is this, and then we are able to do the same thing that we did earlier. So that is return absolute value of a dot zero. We are just uh, using that distance formula, absolute value for this plus absolute value of a1 a1 minus c center, and this should be less than, the whole value should be less than, let me just copy this, instead of a it should be b. So instead of a it should be b, and yeah, we're good to go. So this is just a normal declaration of uh, expected as well. So this syntax uh, like this, semicolon. Yeah, I think it's here. So this is another comparator function which can be declared inside a particular function, and this is nothing. You can just search more about this over any other resource which consists of C++, and now it's working fine. So yeah, so the basic crux was I'm using a comparator. I'm trying to push all the coordinates. I'm trying to compare it using a comparator function, which calculates, which sorts it on the basis of that particular absolute distance value which was given to us in the question, and that's pretty much it. So we move on to the next question, that is FizzBuzz. Now FizzBuzz is a question which is um, very much, it's a basic question which is asked in interviews and something like that. So we need to just display, we're given an integer, we need to display the string, and we return the string consisting of, based on some conditions, answer is um, if answer is I is divisible by 3 for that particular index, then for int I starting from fun, I less than equal to n I plus plus, we try to do if I equal to 3, if I mod equal to 3, equal to 0, we are already trying to declare a string first. So string is str is equal to nothing. Okay. String is just an empty string. So str plus equals to fizz if I modulo 5 equal to 0, we add equal to buzz and try to print this, and otherwise the string would be similar as it is. So otherwise, once this happens, we're able to get a string, and if string is empty, string is still empty. If str equal to this, then we could just str equal to string that particular I variable, and then simply we just push that particular string to the result vector. Push back to str, and that's pretty much it. So underscore. Works for this. This is pretty easy question which is asked a lot in interviews, like basic interviews, not just a pretty easiest question available on Leetcode. Uh, you can have major follow-ups in this question, like uh, of handling such cases like Fizzbuzz. There was a video on YouTube where people were discussing about this question: why is it considered to be like it just tells you to solve questions, and so this particular question is like is asked is not pretty much asked. It's like this question is famous because it had created a lot of controversy over YouTube for some reasons. So you can search on that, and later on we can move to the next question, that is a square triple. ABC is a triple where ABC integers are integers and a square plus b square is equal to c square. Given an integer, return the number of square triples such that AB is less than C, and the given 250, the value constraint is 250, and for n is equal to 10, for n is equal to 5, we can have multiple such cases as 345 or 435. So similar type of thing, and so this is a question. So we are required to find out the number of square sum triples. So yeah, let's just try to solve this. So what we can think of is that in this particular solution, for each and every Pythagorean triplet, let's say 3, 4, 5, we can have another Pythagorean triplet having value as 4, 3, 5. Like these values would be just have their positions interchanged, and this will remain the same because 4 square plus 6 is 5 square. So we could have for each and every triplet, we could have another triplet as 4, 3, 5. So there's one, so for each combination, we can have two variables. So what one thing that comes to my mind is, first we try to for int I. Okay, so let's try to just declare a variable vector int res. We can have n cross n plus 1 and then 0. Why are we doing this? You'll get to know about it. So what are we doing is, for int I is equal to 0, I less than, for I is equal to 1, of course, I is equal to 1, I less than equal to n I plus plus. We're trying to generate all the numbers which are squared. So what we are doing is, this particular vector we can also name it as square. So it keeps a track of all the variables which are squared, right? So square of I cross I is equal to 1. So that means this is doing one thing. So basically it's keeping a track of the variables which are present, or we could just push it. We could just push those values in another vector rather than keeping track of the number of counts, you could just can do is sq dot push back. You could have I cross I star I. So what we can think of is that we have a vector. We have a vector, or another optimization is that we can do is yeah, no, that's pretty much it. Like we could just so we are done with generating all the square terms. So for n is equal to 5, we will have 3, as we'll having 9, we'll having 1, we'll having 4, we'll having 16, we'll be having 25. Such type of vector is generated. Now our goal, our major goal is to try to have a combination of such items and try to generate it in terms of Pythagorean triplets. So how can we do this? We can have for int I is equal to 0, I less than sq dot size I plus plus, and we can just have another variable that is for int j equals I, and I star I plus j star j less than equal to n star n, and we have j plus plus. J plus plus if yeah, so after this what we can have is if I star I plus j star j equal to n star n, we just have count plus equal to 2. We have a variable as count which keeps a track of all the generated combinations, and then we can finally return. This is a pretty new question, like 925, of course, like it's a recent question which is asked. So currently it does not have any question. Output is 4. Why is it 4? Because for when once we are generating 3, for 5, 3 generate for isq dot size I plus plus. So for I is equal to 0, j is equal to I plus plus. Okay, so we are trying to generate some extra cases that we can do it. This try to submit it. Okay, for n is equal to 2, we're getting an error. So right, so what are we trying to do is instead of this would be only calculating for n square. So we not to do this for n square because it might consist of a value such as 3, 4, 5. So what that we can do is instead of generating all the square terms, we could have simple square of I comma I as 1, right? And maximum value would be 1. Square of I star I is equal to 1, count is equal to 0, for int I is equal to 0, I less than square sq dot size. Uh, Instead of sq dot size, there should be n, of course, and we will be generating the j corresponding j for that, and we'll check that if that particular value is present or not. So count plus equal to sq I star I plus j star j into 2. Why 2? Because one pair is I comma j, the another pair could be j comma I, because it's addition. Like 3 apart from 3, 4, we can also do 4, 3. So that's the condition. Count plus equals to a, and still we are not able to get the solution because square of I comma I star I is equal to I plus this. Or what can we do is 1 star I is equal to 1, square of I star I plus j star j. Count j is equal to I. right? So like I realized my problem was instead of I is equal to 0, it should be I is equal to 1 because I is equal to 0, then it would be it can't be a size number because of course I is equal to 0 cannot be a side because here the condition is a should be greater than or equal to 1. So we are not taking the 0 cases. If we try to submit this particular question, I think be okay. Yeah, it's working. So two questions remain, and we'll now try to go to the next question, that is prime number of set bits. So in this question, we are given two integers left and right. We need to return the count of numbers in the inclusive range, that is left and right, having a prime number of set bits in the binary representation. If you just go over through the constraints which is given, so the right will have only the right can have maximum value as 10 raised to the power 6. So if you could just think the range of integers, uh, maximum value is 10 to the raised to the power 6. So we can say that the maximum value that could be contained is in a 32-bit integer. So that means we can maximum have either 32 bits, all of them are set. So the, the maximum prime value that could occur can be only 32 and it cannot be greater than 32. So if we are generating prime numbers, we have two options. One option is we can have a sieve Eratosthenes, which will be later discussed in the further series. And the second thing is we could just declare the number of prime numbers over a set using just a normal set function. We could just declare it as prime, and we could just we could just have all the primes listed over here till number 31, because 31 is a very less number, so we can we can just assume that yeah, we can just list all of the integers. So we have 23, we have 24, 25, 26, 29. That's it. 31, we can include 31. But if you just see that 2 raised to the power 31 would be greater than 10 raised to the power 6. So it's your choice. You might include 31 or not. After this, a simple traversal print I is equal to L equal to till R I plus plus. And then the best thing that we can do is we count till 0, we keep track of the count, and we I y num greater than 0, we can do one thing. Num equal to 2. Before that, you could just count is equal to num ampersand 1. And yeah, once we get num, we could just uh, update it over that particular answer. You just return the number of count of numbers. So int answer equals to 0, and we could just answer plus equal to if we could just say if that particular count is present over the prime set. So if prime dot count variable is 1, that means we can just answer plus equals to answer plus plus, and we could just get an answer. So that's it. I is equal to left, oh, this should be left, and this should be right. Nothing else. I think this will work fine. For 6 and 10, the output is 1. The expected was 4. Why? Because count is equal to num value of count is 357. I okay, so prime not count value of count. See, value of count is coming. Okay, so it was 1, 2, 0, 1. So of course, like 2, Okay, 6 is okay. 6, 7, 8, 9, 10. 6, 6 value is 2. Should not be the case. So 1 value. This should be 1. This should be 1 instead of 2 because shifting it only one time, I guess. Yeah. Okay, this is fine. Let's just try to submit it, and it's fine. Yeah, so avoid these careless mistakes. Like instead of one, I've written 2, which is a problem. You're shifting it only one time. So this is a left. This is a right shift operator. This, and if you try to divide by 2, it means the same thing. Same thing. Uh, Same thing. So we can move on to the next question, and this is the last question for this particular day 1 session. After that, we can say yes, we have completed our day 1 for the first Leetcode speedrun. So given an integer n, each number from 1 to n is grouped according to the sum of its digits. Return how many groups have the largest size. Now n is equal to 13. 4, the output is 4, so there are 9 groups in total. They are grouped from according to the sum of its digits, sum of its digit numbers from 1 to 13. 1 and 10 have same sum, 2, 11 same sum, 3, 12, 4, 13, and so on. So there are 4 groups with the largest size, right? So what can we do is we could have the largest size. The largest size is available. The constraints are 10 raised to the power 4. So the largest size is available can be, as discussed earlier in previous questions, if value is 10 raised to the power 4, so this is the maximum sum which could be generated. That means only 27 sums are possible. So what can we do is we declare the sums as 28, 0, right? 27 is the maximum possible value which could be generated. So for int I is equal to 1, I less than n, I plus plus, we calculate the sum. So int temp is equal to I, and while temp, we try to extract that digit and do the rest of the same. I think you know better what needs to be done. So we have variable as int sum equal to 0, sum int digit, that particular digit is equal to temp modulo 10 divided by 10 for future iterations, and sum plus equals to digit. Could have done it was single line, but plus equals to 10 modulo 10. Once you have calculated the sum, I think we could just use the sums value of sum, and then we can easily do plus plus. After that, what we can do is we can calculate the max value. Max value is equal to star max element sums dot begin sums dot end, and after this we can just do simple traversal over the vector sums. If I equal to Maxwell, then simply we could just say sums of sum plus plus. If the maximum value is the maximum element, okay, the maximum value is 2. So for 2, we can just answer plus plus final answer and just declare this here. So sums of okay, so 13 is happening. 13 is we're doing it for one, right? We're doing it for one. This should be n, right? Also doing it for n. And this should work. So okay, last executed output is 3853. So 3853 something giving us a runtime error. Okay, so 3853. Okay, so the value of 3853 could occur more. 10 raised to the power 4. Value of n is 10 raised to the power 4. Constraint would be 10 to the power 4. Just try to increase the constraints, right? Because let's just assume that it can cross up to 100, right? 100 is a safe bet. While thinking of the constraints, like I don't know, like why did they do that? Okay, so 10 raised to the power 4. Okay, so if you have 10 raised to the power 4, that means you have 4 zeros, right? So the maximum sum that would be generated is 9999. My bad. So instead of 100, it should be 37. 37 because 36 could be the maximum generated sum. So we have 36 possible values. That was a calculation error from my side. Sorry about that. But cool. Yeah, so it's working. And that's just it. And so we can say that we have completed questions of day one maths easy, and I'll call this a session, the first part of easy, because we haven't touched all the problems. We have touched the easiest 30 questions which are available, and for day two, these are the questions that we'll be doing. So I'll just share this with you that these are the questions which are one of the easiest questions that have been asked in several companies. But like this is the easiest question which have been asked. These are not the medium or the hard ones which are asked. So if you are trying to just get the hang of it, just try to solve these easy questions because reason number one, it gives you much more confidence. Reason number two, it just acts as a base that uh, your it just takes care of your worst case scenario that you're not able to try to solve the easiest questions also. So it just removes the fear out of you when you are trying to solve such easy questions. And um, it's fine if you do not have time to solve all 30 questions. I mean, on an average, if you try to solve 30 questions on for a period of 60 days, then you are able to solve all questions. But if you're not able to take out your time, you can just make this a flexible schedule and you can just solve it in 90 days also. Because if you try to solve questions in 90 days, then it would take you to solve 20 questions per day. And 20 is still a good number, it's a great number when you're starting such questions. And apart from this, this was my first recording, so there might be things that you haven't understood. There might you would be having some doubts. So if you face any doubts or issues, you can always message me over Discord, and I'll be there to address your doubts regarding those questions. Also, feel free to check out any other particular discussions or solutions which are present over Leetcode or any other particular source. Apart from that, this was my first recording, so yeah, I have a terrible recording device, and also like this was the first recording, so there might be some couple of issues that would be present. I try to sort these issues out, and of course, the quality of videos and the questions would be increasing with time to time. And yeah, so that's just it. And all the best while solving those questions. I'll see you guys in the next one. And yeah, happy solving.